Okay, guys. Hello. So I'm not going to be here Monday, so I'm recording this ahead of time so that you guys can get the notes that you need and we can keep moving so we don't get behind, okay? So if you have not already, please go into your notes to 3.4. We're going to start talking about angles of polygons, okay? So in 3.1, we talked about side lengths of triangles, that triangle inequality theorem. Then in 3.2, we started with just angles in general and what they are and what their names are. And then 3.3 was angles of triangles. So now we're going into multi-sided shapes, okay? Which is what a polygon is. So we're going to start with some definitions and just understanding what polygons are and what they aren't, okay? So the first one here, we've got terms. A blank is a closed plane figure made up of something. So here we're going to write polygons. A polygon is a closed plane figure made up of 3 or more line segments that intersect only at their endpoints. And we're going to talk about what that means, okay? So here we've got some pictures of things that are polygons and things that are not. These right here, this triangle, obviously we know it's a triangle, is made up of 3 line segments. We've got 1, 2, and 3. And the only place those lines intersect are right here at each endpoint. There's no other kind of line in the middle that's crossing or anything. The only place they intersect is on the ends or the outsides, okay? So same thing here. We've got 3 or more. Here's 1, 2, 3, 4, 5, 6, 7 line segments, and they only intersect at the end points, okay? So there's no craziness happening on the insides of these shapes, okay? So these are polygons, multi-sided shapes, and these are not. I want you to think about why these would not be a polygon. Just take a look at them and figure out for a second maybe why they aren't. Okay, the reason this is because a polygon has to have 3 or more line segments. And if we look here, this is just one continuous line over and over and over and over, right? There's not 3 or more sides. Here, we've got 3 or more line segments, but we have this kind of crisscross going on here in the middle, okay? Which really in turn makes 2 separate shapes, okay? But this shape all by itself is not considered a polygon. And here, we've got 1, 2, 3, 4 line segments, but the important thing here is that they should be straight, okay? And that's what creates this non-polygon, okay? The lines are not straight. Like they would be in all of these other ones that are considered polygons, okay? All right, so let's look at this exploration here. We're gonna look at many, many shapes. And it says, use what you know about the interior angle measures of triangles to find the sum of the interior angles of all of these polygons. So last week we learned that the interior angle measures of a triangle add up to a certain amount. Do you know what that is? Okay, a triangle, the interior angles add up to 180 degrees. So this is 180. So it says use what you know about this to find the sum of the interior angle measures of all of these. How in the world do we do that? Well, all of these shapes can be created using multiple triangles, okay? And what I mean by that is I can take this shape right here and create a couple triangles from it. So I want you to watch carefully here so that you can see what's going on, okay? This is a 4-sided shape, and if I pick any end point here and draw a line diagonally across, it's going to create a triangle. So if I start here at this endpoint and I go diagonally across, I just created two triangles, right? Well, what I know is that one triangle has 180 degrees. So this should be 180, and this should be 180, right? But it says, what is the sum of the interior angle measures of each? So the entire thing together is going to be 360 degrees, okay? This triangle and this triangle together form this entire shape, and all of that together is 360 degrees, okay? So what we're gonna do in each of these is create triangles and then use that knowledge to find all of the interior angles together, okay? You have to pick one specific endpoint and draw lines across the shape. So if I start here, I can't draw to this endpoint because it doesn't create a triangle, right? So I'm gonna stay here at this endpoint that I chose and draw a line across to the next endpoint, okay? That created one triangle, and I can do the same for the rest. So I'm gonna go back to this endpoint and draw another line to the next endpoint. And now I've created a second triangle. Do the same thing with the last point if you can. So here, if I try to draw a line to this point, it's not going to create a triangle. So I don't need to worry about that one. How many triangles did I just create? 3 different ones. But this is 180 total, and this is 180 total, and so is this. We need to add all of those up in order to find the sum of all of those angles together, okay? So once I do that, 180 plus 180 plus 180 is a 4, a 4, and a 5, so 540. All of these together are 540. Okay, so we're just going to continue this process of drawing triangles throughout each of these shapes and then figuring out what the total sum of all of their angles is. So I would like for you to pause and try to do it on your own, okay? And then come back to the video and see if you did it correctly, okay? In the next one here, you can pick any point. I typically always just pick the top left corner, okay? But if I start here and I try to draw a line extending to this point, it doesn't create a triangle. So I'm going to move on to the next one. There's one triangle. I'll start at the same point and move on to the next corner. That creates another triangle. And I've got one more. And I cannot use this point here because it doesn't form a new triangle, okay? So this shape here, I've got 1, 2, 3, 4 triangles. And I know that each of those triangles is 180 degrees. So 180, 180, 180, and 180. Okay? Again, I'm just going to add all of those up and see what the total is. This should be a total of 720 degrees. Okay? Maybe or maybe not at this point you're seeing a pattern of what's happening. If not, it's totally okay. We're just gonna keep going, okay? So the next one, same thing, we're gonna try to create triangles starting at one end point and drawing lines across the shape to all of the other endpoints, okay? This one does not create a new one, but this one does. So there's one triangle. Start at the same point, go to the next one. There's a second triangle. Here's a third, and a fourth, and then this one would not create one. So now I have 1, 2, 3, 4, 5 triangles that are each 180. So instead of repeatedly adding 180 over and over and over, what we can do is just multiply, right? Repeated addition is multiplication. So this should be 180 times 1, 2, 3, 4, 5. So 180 times 5 is what? $900? So this one is a total of 900 degrees. Okay, are we seeing what's happening here? Hopefully. Next one, same thing. So we're just gonna keep going. Pick an endpoint and start extending your lines across to create new triangles. So 1, 2, 3, 4, 5. So we have a total of 1, 2, 3, 4, 5, 6 triangles. And we know that all of those are 180. So here's 180, here's 180, 180, 180, 180, and 180. Hopefully you are remembering now that a triangle is 180 degrees, okay? So 180 times 6 triangles now. Gives us a total of 1,080 degrees in this shape. And then we have one more. Hopefully you can see this all the way over here. So again, pick one more point and start extending your lines, okay? We've got one here, 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 and here, okay? So how many total did that create? 1, 2, 3, 4, 5, 6, 7 total triangles. All of those are 180 degrees, so we can do 180 times 7. And what are we gonna get? $1,260. Okay? Making sense so far, hopefully? Okay, so make sure you have all that written down before we move on to the next part. Okay. So instead of having to repeatedly draw these triangles over and over and over, there's a quicker method, which is an equation, okay? And we're gonna get to that. But it says, use your results in parts A through F, all of this, to complete the table and write an equation that represents the sum of all of those angles inside together, okay? So what this is showing us is each of these shapes had a certain number of sides, okay? Now we don't see the part before A, but this is part A, B, C, D, E, and F, okay? So all of those shapes has a certain number of sides. Previous to this, we have a triangle, right, which is 3 sides. And we know that the number of triangles that a single triangle has is 1, right? 3 sides, 1, 2, 3 is just one triangle. And the interior angle sum is 180 degrees, okay? But then we moved on to a new shape that had 4 sides, 1, 2, 3, and 4, right? How many triangles did that create? Okay, it should be 2. And when it created 2 triangles, the sum of those interior angles was 360 degrees, right? 180 plus 180 gave us 360, okay? Then we move on to the next one. Part B was a shape that had 1, 2, 3, 4, 5 sides. And the number of triangles that we created there was 3. And the sum of all of those angles together was 540 degrees. Okay, so we're just going to complete the rest of this table with the number of triangles that that shape created and then the interior angle sum. So I want you to pause right here and try to complete it based off of everything we just did. And then come back and check it. Okay? So the next one was 4 triangles. And that was a sum of 720. The one after that should be 5 triangles with a sum of 900. Okay, so 1, 2, 3, 4, 5, 900. The next one should be 6 triangles for a sum of 1080 or 1080 degrees. And then the last one was 7 with a total of 1260. Okay, but using this information, we can come up with an equation rather than, again, like I said, drawing every single one of these triangles and multiplying 180 by however many triangles that we had, okay? There's an easier method. And this relates to the number of sides, okay, the number of triangles, and that 180 amount, okay? And it tells us down here, the key idea, interior angle measures of a polygon are the sum of the interior angle measures represented in relation to the number of sides, okay? So if we look here, the number of sides is 3, the number of triangles is 1, and then we've got 180. The rule or the equation here is the sum of all of the angles is represented with S. And we find that by taking the number of sides, n, okay, which it shows us here, the number of sides, n, and subtracting 2 from whatever that number is. And we take that amount and we multiply it by 180. So I want to show you why that works, okay? The number of sides here was 4. If I subtract 2 from that, okay, number of sides minus 2, that gives me 2. What that's telling me is how many triangles are within that shape, okay? So if I take 4 and subtract 2, I get 2. Doesn't this have 2 triangles in it? And what I did there was I multiplied that by 180 to get 360. Okay, I took the number of sides, subtracted 2, multiplied by 180. Okay? So the same thing is going to work here. The number of sides, which I have is 1, 2, 3, 4, 5. 5 sides. If I subtract 2, that gives me 3, right? That tells me there are 3 triangles within that shape, and all I do to find the sum of their interior angles is multiply 180, which is what I did, right? 180, 180, 180. So just multiply by 3, and that gives me my answer here, right? Okay. So we're gonna just take a look at all of this related to that information. The next part here says, the sum of the interior angles is always a blank of 180. That word is multiple. It's always a multiple of 180. Does anyone remember what a multiple is? You learned things like least common multiple. A multiple is basically when you're skip counting, like 2, 4, 6, 8. All of those numbers are multiples of the number 2. Or 5, 10, 15, 20. All of those are multiples of the number 5. So the sum of the interior angles is always a multiple of 180. And that is because there are multiple triangles that have interior angle measures of 180 within them, okay? So here it says find the sum of the interior angle measures. But first what we want to know is what kind of polygon is this? Now we didn't discuss this at the beginning of the lesson, but all of our polygons have certain names, okay? So a triangle is just a triangle, but we know that because hopefully you know this, means 3, which is 3 sides, okay? A polygon is just many sides, okay? So triangle, which means 3, right? But if I've got one that's got 4 sides, do you know what that's called? Okay, maybe you know. It's a quadrilateral, and quad means 4, so that's 4 sides. So this one, how many sides do we have here? 1, 2, 3, 4, 5. So I've got a 5-sided shape. Does anybody know what that is called? Maybe? This is called a pentagon, and that is because penta means 5. Okay, so this is a pentagon. But we need to know the number of sides this has in order to find the sum of the interior angle measures. Okay, we're going to use this equation, the n minus 2 times 180, to find the sum of the interior angle measures. Okay, so n, let's just rewrite the equation. S equals n minus 2 times 180. N is the number of sides. So this has 5 sides, right? So we're going to change n to be 5, subtract 2 from that, and multiply by 180. That's going to give us the sum of these interior angle measures. So 5 minus 2 is 3 times 180 is, anybody? S equals 540 degrees. Okay? So all we're doing right now is just applying this rule or this equation to find the sum. Rather than having to draw the triangles over and over and multiply by 180, we can just use this formula, okay? If I had drawn the triangles, okay, I can pick a corner. I typically pick this one, and I can go here and here. But what we see is 1, 2, 3 triangles, okay, which is what this is telling me, okay? Take the number of sides, 5, and subtract 2. When I do that, I get 3, okay? I have 3 triangles, which are each 180 degrees, which is why I can just take that 3 and multiply by 180 to get a total of 540. All right, hopefully you're following along. Let's look at the next one on the next page. This one's a little hard to see, and it's probably hard on your paper. I know it's like black and white. Maybe you can get a highlighter or something and kind of highlight these edges so that you can see what kind of shape this is. Okay, so first I want you to answer, what kind of polygon is it? Well, you know what kind of polygon it is based on the number of sides that it has, okay? So first let's count the number of sides. We've got 1, 2, 3, 4, 5, 6, 7 sides. Do you know what a 7-sided shape is called? Maybe? It actually has 2 different names. You can call this a septagon, or we also see it called a heptagon. Okay, septa or hepta both means 7 sides. Okay? So a 7-sided shape is a septagon or heptagon. But now what we need to do is find the sum of the interior angle measures using that equation. So the equation, if you want to write it at the top, is S equals n minus 2 times 180. So we're just going to use that to find the interior angle measures, okay? S equals, n is the number of sides, so in this case we're changing n to be 7, subtracting 2, and then multiplying by 180. Okay? 7 minus 2 is 5. Okay? Times 180. Times 5. We can't do that. 0, 0, 4, and 9. 900. All right. So it should be 900. Then the next one. That's probably hard to see as well. We've got this little tiny shape in here. So again, if you have a highlighter or something, you could try to highlight it, okay? But here is our shape. Maybe it's easier if I make it black on this screen. Okay, first we need to know what kind of polygon it is. We know that again by counting the number of sides. So this has 1, 2, 3, 4, 5, 6 sides. What is a 6-sided shape called? Do you know? Should be a hexagon. Hexagon has 6 sides. And now we use that information, plug it into our equation. So S equals number of sides, which is 6, minus 2. We're going to multiply by 180. 6 minus 2 would give me 4. That tells me the number of triangles that are in that shape. Okay, 4 triangles times 180 in each of those triangles would give me a sum of 720. Okay, I would ask you if you have any questions, but you obviously cannot ask me any questions right now, so this is where we're at. All right, let's look at the next part. Reviewing triangles from 3.3. So in the last section we learned that the interior angles of a triangle add up to 180, and we could use that knowledge to find the missing angle. We had to write it out as an equation. It was really, really important that you did that because they didn't always give us nice numbers, so we had to solve the equation in order to find the missing angle. Here they give you the numbers 60, 60, and x. So how would we have gone about solving for that missing angle? I did kind of just tell you. We know that they have to equal 180. So we would have to write an equation. Now, I'm sure some of you are saying, well, just add them up and subtract from 180. You can do that, and that's basically what you do when you write the equation, okay? 60 plus 60 plus x should equal 180 degrees. I want you to get into the habit of writing it out like an equation because it's not always so nice and so simple to solve it, okay? Combine like terms, which are 60 and 60, we get 120 plus x equals 180. And now we need to subtract, okay? So subtract 120, and x should be 60, okay? One of the things that I want to point out to you here is these little lines. These lines mean that those side lengths are the same, okay? So 1 dash on each of those is telling you that all 3 of those sides are exactly the same, which is called an equilateral triangle. And if you remember from 3.1 maybe, that an equilateral triangle is also equiangular, meaning all of their angles should be the same. And we just found out that that one was also 60, okay? All right. So if we remember how to find missing angles of a triangle, we can kind of use that knowledge to find missing angles of polygons, okay? What you first need to know before you even try to find a missing angle measure is what is the sum of all of those together. Same thing that we did up here, okay? We know that they have to be 180, so we use that information to find the missing one, okay? Same thing over here. First thing we need to know is what do they all add up to, okay? And we can figure that out using that equation that we just learned. So the equation is the sum of the interior angles is the number of sides minus 2 multiplied by 180. So we need to start there. Okay, there are a few steps. First is, what do they add up to? Okay, well, we need the number of sides. So this has 1, 2, 3, 4, 5, 6, 7 sides. Okay, so the sum is 7 minus 2 times 180. I want you to figure out what that is. Take a second to do that without my help. Don't wait for me to give you the answer. So we get S is 5 times 180. When you figure that out, we should get, 900. So the sum is 900, but that is not all that you do, okay? That's just telling you that all of these numbers together should equal 900, okay? So what we need to do is add all of the ones that they give us and then figure out what is missing, okay, to get us to 900. I know it's a lot of work, but you gotta do it, okay? Lucky for you, you probably have a calculator or are using one right now anyways. So let's add them all up. We're starting with 115 plus 145. Hey, you're good. I have to record this for next week. Plus 140 plus 128 plus 130 plus 120. Add those all up. And we will have to have plus x in the end to equal 900, okay? We're gonna have to figure out what that is, so don't forget that part. Add them all up, so let's see, this is 18, 1, 2, 6, 10, 12, 15, 16, 17. Hopefully that's right, 1, 2, 3, 4, 5, 6, 7. 778 plus some amount is 900, okay? So here's where that equation kind of comes into place. So 778 plus x has to be 900 degrees. So how do we solve? You need to subtract 778 from itself and from the other side, okay, and figure out what is missing. I know my work is all over the place. 900 minus 778. We gotta borrow. This becomes 8, 10, borrow from there, that's a 9, 2, 2, and 1. So this missing angle here is 122. Now when you're solving for this, you need to make sure that your answer makes sense, okay? So if you leave a number out when you're adding, okay, and you end up with an angle that's like 300 degrees, but all of these other angles are in the 100s, maybe that's not right, okay? Maybe you did something wrong. So they should all generally be around the same number, okay? These are all in the 100s, the low 100s, okay? So if you get some number that's way off of that, you need to check your work, okay? So one of the things I forgot to fill in over here is this polygon has 7 sides, and then we had to write and solve an equation. So we're adding all of these up together and then figuring out what we've got, what we're missing, and what it should be, okay? So that was our equation, 778 plus x needed to equal 900, okay? And then we solved for x. We got 122. I know, it's a lot of work. So let's look at the next one. First thing you need to know is how many sides okay. We're using the formula to figure out what the total interior angle measures should be, and then what is x, okay? So let's start at the first one. How many sides does this have? 1, 2, 3, 4, 5, 6. 6 sides. And now we plug that into the formula, which is the sum of the interior angles is number of sides minus 2 multiplied by 180. Okay? And then we're going to figure out x. So first, number of sides is 6 minus 2 times 180. Well, that becomes 4 times 180, which is 720. That means that all of these angles added together should equal 720 degrees. But now how do we figure that out? How do we find the missing part? Okay, we need to start with what we have all together right now. Okay, so what we have plus x has to equal 720 degrees. Okay, so let's figure out what we have so far. 135 plus 110 plus 125 plus 120 plus 125 again is how much? $615. Okay, so now we can fill this in over here. We've got 615 plus x should be 720. So take a second to figure out what that is. Did you get 105? Okay, hopefully. And that number is pretty close to all of these other ones, so it makes sense, okay? And that's it. So I want you to try this one, okay? Go through this same exact process. How many sides does it have? Plug that number into the formula and find x, find the missing part. Please pause at this point and try it on your own, and then come back, okay? Okay, so start off with how many sides? We've got 1, 2, 3, 4 sides, right? 4 sides. Use the formula. So this becomes S equals number of sides 4 minus 2 times 180. Okay, 4 minus 2 is 2 times 180, which is 360. But we don't stop here. This just tells me that all of these added together need to be 360. So what do we have so far? Okay, we're going to have some total amount plus x that needs to be 360. Okay, that's our equation that we're starting with. So how much do we have right now? Please at this point know that this box means 90, so don't leave that out, don't forget it. And we've got 115 plus 90 plus 80 equals what? $285. So 285 plus x equals 360. So to solve this, we need to subtract 285 from 360, that's an 8, and figure out what we've got. 5, 7, 75? That doesn't sound right. 75? I think that's right. Doesn't sound right though. 5, 15, yes, 75. Okay, so x is 75. All right. Okay, one more I think. Modeling real life. So we've got this building structure here. It says Duo is a mixed use development designer, okay? So he's got some cool little tiles along the outside of this building. It says the Duo development in Singapore features 2 buildings covered by frames in the shape of a regular hexagon. What it means by regular is kind of like what we would mean with an equilateral triangle, okay? Meaning all of the sides of that hexagon are the same, okay? And that's really important to know in order to answer this question. So all of these hexagons that are on this building are exactly the same, and all of their side lengths are exactly the same. And when I told you that about that triangle, an equilateral triangle, when all of those sides were the same, all of their angles were also the same, right? Okay, all of them had an angle measure of 60. So the same thing is going to happen here. But what it asks you is to find the sum of the interior angle measures, okay? But what it also wants to know is what is the measure of each individual angle, okay? Find the measure of the interior angles. So there it's not asking for the sum. First we need to know what they all need to add up to, and then we need to figure out what each individual angle here, what this angle is or what this one is, and so on, okay? It's asking for those individual angle measures. So I want you to think about where we need to start. It does say you need to use the formula. Okay, so that formula that it's talking about is S equals n minus 2 times 180. So how many sides does the hexagon have? 6 minus 2 times 180. Which is what? 4 times 180. So all of these angles added up together should be what? Do you have an answer? $720? But that's not what it's asking us, okay? It says find the measures of the interior angles, okay? So if I know that all of these together need to be 720, and I also know that every single one of these angles is the same, how am I going to figure out what just one of these equals? What are we thinking? I need to take this 720 and split it up evenly between each of those angles. So this has 1, 2, 3, 4, 5, 6 angles that all need to be exactly the same, which means I can take this 720 and divide it by 6 and figure out what each of those is. Okay, so let's solve this. 6 goes into 7 one time, with 1 left over. 6 goes into 12 2 times, with nothing left over, but I still have a 0. That means that each one of those interior angles is 120 degrees, okay? So each angle is 120. Okay? Good? All right. I think that's it for this. So you can attempt the homework now. We'll say that the homework will be due on Wednesday. That way you can ask any questions in class. On Tuesday, we'll just kind of go over this together and do some extra practice and just keep going with this, all right? So just do your best to try to answer these. I would say let's do all of them, okay? I know that's a lot, so just do what you can for now. We will finish the rest tomorrow in class, and we'll just keep practicing, all right?